Hello and welcome back to another holistic education video. And this week we'll be continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. And in this video we'll be looking at problem number 9, which is a very tricky geometry problem because it gives us a lot of details but no visuals. And so it is up to us to draw out and visualize this geometry problem ourselves. It says a circle has center G and points M and N lie on the circle. Line segments MH and NH are tangent to the circle at points M and N respectively. If the radius of the circle is 168 millimeters and the perimeter of the quadrilateral GMHN is 3,856 millimeters, what is the distance in millimeters between points G and H? 168, 1,752, 1,760, or 1,768. So, this is going to sound very confusing in just words. We need to draw it into a picture to understand it better. So let's do that. So let's start off by drawing ourselves a circle. So here we have our circle, and at the center of that circle is point G, as we've talked about. There's two other points on this circle, point M and point N. And then there's two line segments that come out from the circle at a tangent. And those line segments are MH and NH, which means they both meet at some fourth point H. So we can kind of draw this out. We can draw a tangent line out from M and another tangent line out from N and have them meet at a fourth point that we will call point H. And it says that the perimeter of the quadrilateral GMHN is 3,856. So that quadrilateral would include these lines coming from G and going to M and going to N. Now, couple important things to notice here. Firstly, these two lines that go from G to M and G to N, these are both radii of our circle, which means, according to the description of the problem, we already know what their length is. It says the circle has a radius of 168 millimeters. Both of these line segments are radii, which means both of these have length 168. Secondly, these line segments MH and NH are tangent to our circle. And whenever you have one that is tangent to our circle, we know that that is a right angle to the radius at that point. So this radius is perpendicular to this line segment MH, and this radius is perpendicular to this line segment NH. And lastly, it's asking us to find the distance between the points G and H. In other words, the distance of this line, which I will draw in red, from G to H. So, how can we use all of this information that we have right here to find the length of that line? Well, one of the important things to realize is that these are both right triangles. This triangle GNH and this triangle GMH are both right triangles because of this right angle right here. Which means if we can find the length of one of these line segments, we can use Pythagorean theorem to find the length of the hypotenuse, or in other words, this GH line segment. So how do we find the length of one of these line segments? Well, fortunately, we know that the perimeter of the quadrilateral, and I will write this out, the perimeter of GMHN is 3,856. So we know that the sum of these four line segments equals 3,856. But even more than that, because these are identical triangles, we know that each half of this quadrilateral is going to make up exactly half of this perimeter. So, in fact, we know that this half, this GN segment plus this NH segment, is going to equal exactly half of our perimeter, or in other words, GN plus NH will equal 1,928, half of this 3,856. Also, furthermore, we already know the length of this GN segment because this is a radius of our circle. So we know that 168 plus NH equals 1,928. And now it is very simple to find the value of this NH line segment. Quick note, we could have done the exact same thing for this other triangle and find the value of this MH line segment. They're identical. I'm just going to go ahead and do this one. But now if we subtract this 168 from both sides, we'll see that NH equals 1,760. So now let me redraw this triangle here, down here, just so we can see it a little bit better. We have this radius at the bottom from point G to point N, and that is 168. We have this line segment from N to H at a right angle. That is, we've just calculated 1,760. And then lastly, we have our hypotenuse, which represents this segment from G to H right here. And this is the value that we're trying to find. But of course, because this is a right triangle, we can very easily use Pythagorean theorem, which states that this GH length squared equals this GN length squared plus this NH length squared. In other words, the value of GH right here that we're looking for is equal to the square root of 168 squared plus 1,760 squared. And if you plug this into your calculator, you will find that this equals 1,768. 1,768 is our final answer, and that corresponds to answer choice D. So D is our final answer, and this is a great example of a problem where you really have to draw it out and visualize it yourself because there's so many different pieces to really understand what is going on and how we solve this problem. Thank you so much for tuning in. I look forward to seeing you in the next one.